So, hi, I have a question here.
Yeah.
I want to understand whether the CXL protocol under the hood is making use of, at which layer does it bifurcate from the PCI stack? I mean, is it
Right.
still using DLLPs underneath it, or it is still using TLPs underneath it?
Right. So, okay, I'll tell you this, right? Okay, let's go to this picture. Yeah, this picture, correct? Okay, see, for the CXL, if you see, it uses a completely different transaction layer, link layer, and so the 5 layers as well. Okay, whereas if you are in the PCIe or the CXL.io mode, it pretty much behaves like PCIe, correct? So all your TLPs and the other what do you call the ACNAC mechanism and everything else remains the same, right? Whereas on the CXL.cache and CXL.mem, both transaction link layer, they are newly defined, right? Including the OR-MUX layer. They are newly defined. And of course, the 5 layer is borrowed from PCIe.
So will I be right to make a statement that for CXL to operate correctly, I need to have CXL compliant devices, root complex, as well as PCI switches?
Right. So, see, okay, important observation to make is, as of now, CXL is made to work point to point, right? So it can't connect to a PCIe switch. So that is still work under progress. So you got it right. You got what I'm saying, right? So
Yeah, I got the point to point thing.
it has to be a point to point, and it cannot connect to a switch as of now. So that's the observation that I want to make.
Okay, thank you.
Yeah.
Hi Madhu, Girish here. Thanks for a nice presentation. So I have one question. As that CXL is built on top of Gen 5, so is it mandatory to have operate all the times on the Gen 5, even though both the device host and device supports are lower speeds? So definitely it supports a lower speed, so it can come down to a lower speed and work at the lower speed as well.
Yeah, so it can work at a lower speed, right? So it is not important to actually have the say Gen 3 or Gen 4 speeds, but Gen 5 is proposed because the as part of Gen 5, as I told you, an alternate protocol mechanism is defined, right? I think I'll try to explain as much as possible. What happens is, this alternate protocol is actually negotiated during the link training time, right? You have the TS1, TS2, right? So new TS1, TS2 is defined, which will allow the root complex to find out whether this has capability to support CXL or PCIe, and accordingly, the device is configured. So after that, it is not essential actually that you have to work in PCIe Gen 5 speed or something like that. So that's not what it is. It can, again, the lane width can also be different.
Okay, thanks, Madhu. Another question I have is like, as you said, the PCI IO is similar to as a PCIe, but the CXL and a MEM are a bit different, and they are supported by a FLIT, right? But IO is not supported as a FLIT. So with the IO and CXL MEM and cache can coexist together, or when you are switching from IO to MEM or MEM to IO, do you need to change and inform the device appropriately?
No. So it can dynamically switch between IO, memory, and cache. So as I told you, IO is only going to trickle, right? So it's not going to be a very high, bandwidth transaction on the IO. So IO transactions will not matter, and they can be dynamically be muxed. So IO transactions, memory, and cache.
Okay. Yeah. Thanks, Madhu.
Madhu, I have a question.
Yeah, sure.
Shrikul here.
Yeah.
So the thing is, you mentioned that CXL is low latency because of the close proximity to memory. Now I can do the same with the PCI device as well, right? So is it just the proximity to the
No,
memory that does that?
no. So see, there is a vertical optimization that has happened, right, to make this CXL low latency. As I told you, if you just look at the PCIe packets, the smallest packet that you could have is 128 bytes, correct? Whereas in the CXL, you could have flits which are just 512 bits, right? So that makes it easier for you to have the memory semantics or the load store transaction. See, PCIe is pretty much an IO bus, right? Initially, so what happens is it is more suitable for doing block transfers. Right? Anytime you go outside of the CPU, you tend to bring and transfer as much data as possible in bulk. So that is what PCIe was built for. Correct? Even though they support the MMIO operations, again, they are not highly optimized for low latency.
Okay, and what about the atomics? So in PCI, it's all like, since there is only one equivalent of IO,
Right.
where do the atomics happen here in CXL? Is it cache mem or in the IO?
Right. So when you say atomics, are you talking about let us say some kind of say read and do some compute operations like add,
Yeah,
subtract,
like
multiply, and then
fetch
write it?
and add. Fetch
Right.
and add is a classic one, something
Yeah,
like
yeah.
that.
So to be very frank, I haven't seen any constructs to do that as part of this protocol.
Okay, I see.
Yeah.
So a CXL device would still be having similar, the topology. It would still have a bus device function number, and it would be enumerated just like a PCI device. I mean, the same.
Correct. You are right.
Okay. So basically, CX.
Madhu, sorry to interrupt. One question there. The CXL 1.1, doesn't it say it is RCIEP, right? So it won't enumerate like a normal PCI device.
Yeah, that is, see, it actually, whatever is defined in PCIe Gen 5 is what is, RCIe IP, and it will follow that protocol.
Okay, but not as an endpoint. It will
Right.
be an RCIP.
Correct. That's what, so this is, as I told you, it cannot go through a switch, right? So that's what makes it to behave like that.
Okay.
Hi, Madhu.
Hey, I think somebody has to put it in mute.
Hello, Madhu.
Yeah.
Hi, my name is Shankar here.
Yeah, Shankar.
Yes, in fact, I'm not the technical person. I have a company called Coral Human Resource Consultants. Out of curiosity, I joined your webinar. I wanted to understand what is the cache, coherency, and all that. When I'm hiring the people for this particular positions, then, actually, I had interacted with you anywhere in your seminar, right?
Don't think that's correct because
Just a second. So, guys, please
Hello?
go to mute if you are not talking. Shankar, can you say again?
Yeah, I'm Shankar here. I'm from Coral Consultants. Okay, we are into manpower recruitment. Out of curiosity, I joined your presentation. I was kind of going through cache and coherency. I wanted to understand how it is, what it is, and all that. When I'm hiring the people for these kind of positions and all that.
Mm-hmm.
So, out of curiosity, actually, I knew about you, and when you had founded a company called Reverse Ilka, right?
Right,
Long
right.
back. I had interacted with you that particular time.
Oh, okay, okay, nice. Okay, okay.
I'm in the industry for the last about 12 to 13 years. So
Okay.
working for quite a few companies. I came to know about your presentation through Kishore. I thought, let me kind of attend now. What is coherency? What is PCI Express? What is Gen 5 and all that? I really understood. Thanks for your wonderful presentation, sir.
Yeah, no issues. Welcome. Thanks for
Okay. All right. Thanks, guys. And go ahead. Thank you very much. All right. Thank you. Thank you.
So, Chandana, you were asking some questions.
Yeah.
Yeah, I think she got disconnected. I think some echo.
Yeah. Hi, Muthulan. Thanks for the presentation. So I have a couple of questions. My name is Kotresh.
Hey, Kotresh. Yeah.
Yeah. I have a couple of questions. Like when we say like CXL provides all the offloading mechanism, so does it provides virtualization for PCI Express, or how it works actually? So does it support IO virtualization as well, or is it just directly the device will directly interact with the DMA and then the transfers happen?
Okay, so so when you say virtualization, right? So you are talking about the multiple functions and things like that, right?
Correct.
Right. So I'm not sure, Shankar. I need to get back regarding that.
It's Kotresh here, sir.
Yeah, sorry, Kotresh. Yeah.
Yeah.
I'll check and I will let you know.
Okay, so I have a second question. So you also mentioned that this also brings opportunities for the AI and ML interaction at the acceleration level. So what application do exist and what opportunities people can make use of it?
Okay, so see, as I told you, one of the important thing is the computational storage devices, right? CSDs, as they call it, right? For example, when you have actually the trained data or the data to train, it's a huge set of data, right? Such data will typically be stored inside the storage, correct? Let's say NAND memory, right? And if the CPU can offload some part of let's say the training algorithm that needs to be done to this computational storage engine, it could actually do it without tossing the data from the storage to the main memory, and then again the CPU or say the accelerator again working on it, and then again sending the data back. So you can avoid all these things and do things in place, correct? So that is one possibility. So people are talking about, and yeah, that's what is computational storage device. So if you are interested, you could take a look at SNIA. There is a Storage and Network Industry Alliance. You can take a look at it. There is a separate work group that talks about CSDs. So that could be of some interest to you.
Okay, thanks.
Yeah.
Hi, Madhu. I have a question about CXL.cache. It's like we know that multiple SoC makers follow their own caching coherency protocols. Like
correct.
Probably Intel may follow MESI, AMD may follow Moisey, and the devices also come from multiple vendors. So.
Right.
So in case of multiple cache states, how does, with multiple SoCs or devices, how does the CXL, coordinate between those?
Right. So see, it's a CXL device. In this case, the CXL standard, right? Only if you look at the cache constructs that are being discussed in the CXL spec, they pretty much follow the MESI model, MESI model, right? So even if you are implementing a MOSI or whatever, they will definitely implement these states. And if you are a CXL compliant host, you have to actually implement these states.
That's right. That means if they are following MESI or something, if I as a SoC maker, if I have one additional state, I have to downgrade my caching coherency state, one state as such, you're saying?
Right. So when you talk to the CXL device, and when the CXL device requests to the say the home, it can only talk in terms of this language, right? It can only understand these 4 states. So that is what the home is also supposed to do.
Okay. Okay. All right. Thanks.
Yeah.
Oh, Madhu, I have a generic question. So, if I'm not wrong, the CXA is based upon PCI 5, right? So, it is not applicable to PCI 4. Am I right?
Correct.
Right. So then my subsequent question will be that you said like the PCI and the CXL kind of get into the same, the PCI slot. That said, in the typical accelerator use case, we used to have a PCI switch, right? So is the current PCI switch is capable of handling the CXL and the PCI combination protocols, or we need something called as an CXI switch? We have to put in, or can you just throw some light in terms of like in those directions how it will be dealt with?
Right. So see, as far as I understand, right, you cannot have a CXL device today and just connect it to a PCIe switch or to the existing root complex now. Okay. So it has to be a PCIe Gen 5 compatible thing.
Right. Let's say like it's a PCI Gen 5 compatible, but we used to have a PCI switch, right? Which
correct.
Arbitrate between your multiple endpoint or the root complex, right? And that's how the accelerator will have, right? We have multiple dice, let's say for a complex accelerators.
Correct.
Understand how will that handle CXL kind?
So see, as of now, the CXL specification, right? Whatever spec I have, right? So I am I'm not part of the spec committee, right? But I understand from some other forum that CXL 2.0 actually talks about putting the CXL device behind a switch, right? PCIe switch. So for now, as I understand, it has to be a point to point, and you can't have a switch or a routing mechanism in between.
Okay, fine, correct. And by the way, we just discussed again, this works on the PCI 5 on top of it. So does that mean the CXL protocol goes into the PCS kind of a soft layer, or how does it kinds of wraps around the existing PCI?
No, say again, Dhanpati, I think I missed you.
Right, I say it again. So the CXL also works on the basics of the PCI PMA, which is fundamentally the analog 5 that we have, I assume, right? So what my query is that if the PMA is the same, so will the CXI protocol will get into a PCS layer, which is we call it as raw PCS and soft PCS typically if we take it, right? So will it go into PCS layer and then kind of like manipulate, or maybe the algorithm or the protocol works in that layer, or how is that actually the CXI is used on top of this PCIe PMA is what my fundamental question is.
Okay, so to be very frank, I am not aware of the mechanics of how exactly it happens inside the PCS and PMA layer, because I have not gone through the PCIe 5 per se. I have not gone through that specification, so I don't know.
Sure, no problem. Thanks.
Yeah.
Madhu, can I add to that?
Yeah. Go ahead, Srikul.
Yeah, it's exactly the same as what PCI 5 is. When you talk about the physical interface, all electrical PCS PMA all remains same. There is no change as compared to PCI 5.
Okay, great. Thanks for that information, Srikul. It helps.
Thank you, Srikul.
Okay, maybe one or two more questions. Otherwise, we can actually finish this presentation.
Yeah, Madhu. So, can you throw some light on the verification, validation, and the emulation part for this protocol? Is anything exists and someone is working? Can you give some pointer on that?
Yeah, sure. So there is a whole lot of compliance test specification that the spec itself talks about. So this for verification engineers, I think definitely this is going to be very, very interesting, right? So with the cache transitions and so many different things that are possible. So it is an exciting thing for verification engineers. But as far as I know, there are some companies that already have the VIPs to verify, And regarding validation, I am not sure as of now, because validation will require the actual 5 support, PCIe Gen 5 support. So I don't think that there is any device, FPGA or otherwise, that support PCIe Gen 5 today. They probably will come to the market after some a year or so. So that's to answer your question, Devashish.
Madhu, I have a question.
Yeah.
Yeah, actually, this CXL, I'm new to CXL.
Okay.
So normally in this storage domain, we have some maybe memory read or memory write from the CPU, and maybe to enhance the performance, we do some kind of caching inside the device and give the data directly from the cache, right? So is it something this cache CXL, CXL.cache is related to something which is related to caching inside the storage devices?
Right. So it is related to caching inside the device. So it is about caching of the DDR or caching of the host memory locations inside the device. For example, you consider this device to be as one more CPU, right, with its own local cache. So, that's the kind of topology we are talking about, right? So there is a CXL device that can have a cache inside, which can cache the memory locations or the host memory locations. So how do you maintain the coherency if let's say a particular cache line is shared across multiple CPUs, which is also there present inside this CXL device cache, right? So that's what is addressed by CXL.
Okay, Madhu. Yeah.
Did that answer your question, Sharath, or it's something different? What you are asking?
Actually, I was thinking in a storage protocol point of view, like NVMe or something like that. So, but it is a little bit different, right?
Right.
Yeah. Okay, got it.
Madhu, even today the devices have cache, right?
Correct.
So there, there, how is the caching actually maintained? I know a little bit, but not very sure. If you can just explain in 1 or 2 lines.
Even a GPU, for example, has a cache, right? So, but it is private to the GPU. It is not coming under the coherent domain of the CPU, correct? So, for you to bring the caches and the memory which are used by these devices to be part of the coherent domain of the CPU, you need to have you need to implement this protocol, right? Cache protocol. So that's what it is.
Okay, today I think probably only flush and invalidations are supported. With this, we'll support all these cache states, right?
Yeah, all the cache states, exactly like how it is happening inside a CPU. You could do that in a device as well now.
Okay. Thanks, Madhu.
Yeah.
Madhu, a question on CXL and how does it work along with any other protocol like NVDIMP? Is there any integration possible there, or?
Right. So NVDIMP is based on the DDR protocol, right? DDR4 or DDR5.
Right. Yeah.
So CXL, because it's based on PCIe, it actually allows you to come out of the say the CPU slot, right? The DIMM slots, and put this device outside, right? So one thing what I can think of is like you could have a bridge that converts from say the NVDIMM to say this CXL or the other way, but I don't think that will be efficient, right? So NVDIMM is for a different use case, and I think CXL is for a different use case.
Right. Okay. And how this differable memory write is actually implemented in the CXL case? So you talked about the differable memory right in one of the slides.
Right. So see, as I told you, the PCI writes are posted transactions, right? So there is no response that goes back to the requester. Whereas with the deferable writes, you now have a means to know that actually that write completed successfully, right? And the target side. So that's what that kind of a feature is what comes to you when you use the deferable writes.
Okay, but from the
Let's
protocol,
say, yeah.
go ahead, Madhu.
Yeah, so when you do a write and then read, you could have you could push it this way, right? You could wait for a deferable write and then you could do a read or something.
Okay, I mean, is there any anything defined from the protocol per se to take care of the deferable write in terms of weight, or how's that maintained without any conflicts in terms of cache being invalidated?
See, as I told you, deferable writes are implemented as part of the CXL.io, correct?
Right.
Yeah. So there is no concept of cache that is there. So yeah, I think it's not related.
Okay.
Yeah. Okay. So right. So thank you very much, everybody, for great questions. It was, I think, a very good interactive session, a learning experience for me as well. Right, because CXL is very new. I think everybody is trying to explore. Right. So thank you very much. And this is my email ID. I'll try to share this presentation to you over email. So if you have any further questions or you want to discuss, I'm available to discuss. And this is my email ID. Once again, thank you everybody for the great interactive session. And, we will probably meet again with some other topic, or maybe we can talk about the same thing again. An extension or deep dive sessions related to CXL. Stay safe. Bye.
Thanks.
Thank you.
Thanks,
Thanks, Madhu.
Madhu.
Thanks, Madhu.